All right. Okay. So if you remember yesterday, we talked about doing the point-to-point foot candle calculation. The point-to-point foot candle calculation. I don't know how many of you guys remember that. Point-to-point foot candle calculation. This one is continuing on it. If you go to chapter 5, they have three lights. Well, they have more lights, but I picked three lighting fixtures from chapter 5. Each one of these blue are lighting fixture at the top, as you can see here. These are lighting fixtures, lighting fixtures, lighting fixtures. They're 70 watt, I believe, metal halide or high pressure sodium, 70 watt. I have fixture 1, fixture 2, fixture 3. They are located 10 feet apart, and they're mounted at 10-foot poles. Everybody knows what the scenario. We're mounting them at 10-foot poles, and they're located 10 feet apart. So the ratio, Chris, is 1 to 1. The mounting height to the distance is 1 to 1, not 1 to 2. 1 to 1. Okay, and the question would be we need to find the foot candle. We need to do a foot candle calculation. All of them, by the way, are the same size: 70 watt, 70 watt, 70 watt. Typical in the parking lot. And we need to do the calculation at point A, point B, and point C. Now you can imagine you can do a calculation at any other point, but we picked these 3 points because they have a value or a point to see. The formula that we're going to be using is, all of you have this one. The formula is exactly what we did yesterday. It's the CP multiplied by the cosine Q with the vertical, the Q with the vertical, not horizontal, raised to the power 3, and then divided by MH is the mounting height, or H. You can call it H, the mounting height raised to the power 2, and there is a derating factor called guard factor or maintenance factor. You're gonna, when you do the calculation at the end, there's some type of a derating factor. In this case, that derating factor, what they call it guard factor, because when you have a guard at a fixture outside, it will absorb some of the lights. It will absorb some of the lights, and it wouldn't allow 100% of the light to go out. So we're gonna compensate for this so-called guard factor or maintenance factor later on. It's given, the guard factor is given as 0.88. 0.88. So
similar to the maintenance factor.
it's actually in addition to the maintenance factor. We're assuming here that the maintenance factor is 1, so we're really maintaining that baby good, so everything is cool. But there's one little issue. We're having a guard on the fixture, and that guard will reduce the amount of light coming out of it. In addition, so the question would be for me, Chad, where's your maintenance factor? My maintenance factor is assumed 1. Any question, Ashley? Questions? Any question, guys? Okay, so you have it in front of you. All this info that I'm looking at, guys, you have it in front of you. Do me a favor, go to Fig 5.3 because that's where the info is coming from about this particular fixture. Otherwise, there's nothing you can do. If you go to 5.3, the fixture that you're looking, what did we call this one? The photometric data. The photometric data for that particular fixture is given in 5.3. Without this 5.3 photometric data, here, bud, that one. There you go. We just started. 5.3, Fig 5.3. Without 5.3, you cannot do this problem, right? You need the photometric data, and thanks God for the visual and all the other softwares, otherwise it will be tedious to do. Okay. So any question, guys, about the problem? I'm taking only one problem. I have 3 fixtures mounted 10 foot high, spaced 10 feet apart, and I need to find the foot candle at only 3 points. You can point it at as many points as you want. At only 3 points. One right underneath the fixture 2, one right underneath fixture 1, and one right underneath fixture 3. And we need to do the calculation to find the light at fixture A, the light at fixture B, and the light at fixture C. And Ashley, just before we go, looking at the geometry, you guys agree with me that when I do the calculation right at point A here, it will have contribution coming from fixture 1 and contribution coming from fixture 2 and from fixture 3, right? Everybody agrees with that? So I have to have contribution coming from the 3 fixtures. When I do B is so easy because the contribution coming from at point B, there's light coming from from 2, and there's light coming from 3 and light coming from 1. The light that's coming from 1 and 3 are identical because of symmetrical. Can you guys see the symmetrical? That triangle from here to here, this triangle is symmetrical. So when I do the calculation from point 3 at B, it's the same calculation from point 1 at B, right? Because it's symmetrical. It's symmetrical. Okay, so let's go ahead, guys, and find the calculation. And the other symmetrical, just look at the symmetrical. That's why it's really nice because you don't have to do all the calculation. Can you guys, can everybody look at this? And can you tell me if I do the calculation at A, right? Just right here at A. You think the foot candle at B will be the same? I mean at C. How about C? Yeah. Do you think C and A calculation would be the same? Because of symmetrical. Absolutely. The contribution from here to C is exactly from 1 to A, exactly like from 3 to C. And from 2 to A is exactly like from 2 to C. And what else? And from 3 to A is exactly like from 1 to C. So these are symmetrical. I don't need to do the calculation for them. I can't emphasize that when you draw the things, guys, look at the symmetrical. It makes your calculation much easier, faster, and you don't have to do all these. Okay, so what are we supposed to do here? We're supposed to find the calculation at 3 points from 3 lights. At 3 points from 3 lights. So every point is going to have three calculations. Every point is going to have 3 calculations, and we're going to add them up. So at point A, I need to find the calculation from fixture 1, and the contribution from 2 and 3, at B from 1, 2, and 3, and at C from 1, 2, and 3. Cool? Everybody got that, what we're doing? Because there are 3 fixtures. And then we're going to add them up. Okay, so you guys have the info in front of you. We're going to start by finding calculation at point B. So I picked point P to start doing the calculation. You really don't have to do that. You can pick any one of them. I picked B because it's the easiest. Okay, the first thing, if you guys look at B, at point B, there are 3 calculations. One calculation at point P, I'm going to call this calculation 1, calculation 2. So calculation 1 is coming from fixture, you know, it's confusing to put 1 and 2 here because of the, so the first calculation is coming from fixture 2. Here's 2 down to B. What's the angle from 2 to B? 0. The angle from 2 to B is 0. So by the way, when I do the calculation, I need to find the CP. Here you go. I'll order for my friend. Oops. Let me give you one of these. When we do the contribution, guys, when you do the calculation, you need to find the CP and the angle, and the mounting height is the same. So really, you need an angle and CP. Okay, let's go ahead. At point B, contribution from 2. So I need the foot candle. The angle is what? The angle is 0. Can you guys go to Fig 5.3 and find me the CP at angle 0? The CP at angle 0. I want to remind you that I put 10 points for contribution and participation. So that's when I ask you and you give me, that's when you get 10 out of 10 in participation. Just a quick friendly reminder. Okay, so at point 0, everybody can see that at point 0 we have 949 from Fig 5.3, page 50. So this is from page 50. Everybody knows where we are? In the lighting book, page 50, Fig 5.3. 5.3. Okay. All right, so it's 949, and Nick, my friend, it's 949 lumens, right? It's a lumen. Okay. So now I'm ready to do the contribution of fixture 2 at point B. Piece of cake, Chad. The first thing you need to do the guard, which is the guard is 0.88. Multiply this one by the foot candle or candela power at the angle, which is 949. And then don't forget to take the cosine of 0 and raise it to the power 3, please. And then divide everything by the mounting height, which is 10 raised to the power 2. Okay, so the guarding factor, 0.88, the rating factor, then the lumens multiplied by the cosine of 0 raised to the power 3. Did you come up with an answer, Nick?
8.35.
8.35, identical. Awesome. So my answer would be 8.35, and the answer would be what? Thank you. 8.35 foot candle. So it's an 8.35 foot candle. 8.35 foot candle. So the contribution of fixture 2 at point B is actually 8.35. 8.35. Any question, guys? Any questions? Okay, so we're done from 2 to B. Now we're going to go find it from fixture 1. From fixture 1, this is from fixture 2. Now we're going to go find it from fixture 1. Find the constant. Any question, guys, from fixture 2 to B, how we came up with 8.3, right? Now let's go find the contribution from fixture 1. From fixture 1, guys, I don't know if you can see right here, I have the distance. Everybody can see from 1 to B, I have a triangle here, and the triangle, two sides, 10, 10, and I need to find the angle. I need to find the angle. This is where you get into the tan. Everybody knows from fixture 1 into B, the angle is called Q1. To find Q1, Q of an angle, what's the tan of an angle? Opposite over adjacent. The opposite is 10 over the adjacent is 10. So the tan of an angle is 10 over 10, right? And it doesn't take a smart gentleman to get you 10 over 10 is what? 1. And then you take tan inverse. Everybody knows what tan inverse is, or inverse tan? Inverse tan is when you know an angle's tan, you can find the angle from its tan. Or inverse sine or inverse cosine, right? Everybody knows the inverse of a sine, the opposite, basically. If you know the tan, you can find the angle. If you know the angle, you can find the tan. One more time. Any question, guys, why the tan of Q1 equals 10 over 10? Because the tan of an angle is the opposite. We're talking about this angle right in here, Q1. It's the opposite 10 over the adjacent, opposite over adjacent, right? Phil, does it make sense? Opposite over adjacent, 10 over 10, 1. So this is tan Q is 1. Now, if I know the tan, I can find the Q then. So they call it inverse tan. Inverse tan 1, you have to put 1 here, equal what? What's the angle that has a tan of 1? Everybody knows how to do in a calculator? Based on your calculator, inverse tan, and you type 1, that will give you 45, right? 45, thank you. So my angle is 45 degrees. That's exactly what you were saying yesterday when I gave you the angle. Say, well, normally you don't have the angle, you have the distance. Exactly, that's where this chapter do the regular stuff. When you have a distance, you don't have an angle, you find the angle. Anybody knows why I found the angle? Because if I find the angle, and I can calculate, I can plug it into this formula. Without the angle, I'm dead. Okay. Before I move on, any question? Why did we do the tan and inverse tan and so forth? To find the angle. You need to find the angle. The angle from 1 into B. 1 into B. There's Hal Evans online. Any question, guys? Okay, so let's go ahead. So since we know the angle, and you guys have this one in front of you, since we know the angle is 45, so I'm gonna go grab my 45 degree angle. Doesn't even look like a 45, okay? So I'm gonna go grab the 45 degree angle, take it to page 50, fig 5.3, and find the contribution, lumen contribution of this fixture at this angle. And Chris, my friend, if you're looking at it, anybody can read it for me? The contribution at this angle?
1039.
1039. Thank you. It's a 10 and a 3 and a 9. And what's the unit? Lumens. 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 Okay. So we have lumens. Okay. Now, since we know the lumens and we know the angle, it's a piece of cake now, Chad. Go ahead, bring it on, huh? So let's go and find, it's a 0.88 multiplied by the contribution is 1039 times cosine 45 raised to the power 3. Divide everything by 10 times 10. And if you do this, everybody knows how to find cosine and cubit. It's a piece of cake, right? Yes, sir.
I'm just a little confused by the area of 10 by 10.
10 is not an area, it's the square of the distance. The mounting height. It's the mounting height squared.
Okay, mounting height.
Yep. It gives you an area though. If the unit is an area. If you look at, because foot candle is defined as lumen over area. So eventually it will give you an area. Right? You have to. Because a foot candle, guys, is defined as lumen over an area. So but the 10 by 10 is coming from squaring the distance. Any question, guys? Anybody? What's the answer for that one? What? 3.23. Thank you. 3.23. And the unit for 3.23 is what? Foot candle. Thank you. Foot candle. Huh? This is from 2 to B. No, I'm sorry. Let's go back. That was from 1 to B. From fixture 1, can you see where fixture 1 is here? Into B. From fixture 1 to B. Fixture 1 to B. Now, before we move on, guys, everybody knows if you, from 1 to B, can you see from symmetrical triangles that from 1 to B is identical to 3 to B? Do I need to do the calculation again? No. So when I give you the test, guys, it might look like you have to do 15, 6, 7 calculation, but with symmetrical, it cuts it down to 2 or 3. Okay? Everybody knows why contribution of 1 at B is the same as contribution 3 at B. Now here's where I can, or you could, you could be screwed up. If fixture 3 is different than fixture 1, now you're doomed. If you have identical fixtures, identical height, spaced identical, then everything is identical. The contribution will be identical. So there is no need to do the calculation again. Okay, so at fixture 3, so from fixture 3 at point B, the contribution will be identical, 3.23, and why? Because of symmetrical. Symmetrical triangles. The triangles are symmetrical. Symmetrical triangles. Any question, guys? Do I need to do the calculation for? Everybody's following with me? How symmetrical triangles? Symmetrical triangles. Okay. All right. So then the total foot candle at point B. Now remember, there are 3 fixtures shooting light at point B, so I need to find the total. Add them up because they're coming from 3 fixtures. When you add them up, you're going to add 8. The first one is 8.35 plus 3.23 plus 3.23. And if I did my math right, that will give me 14.87 foot candle. Foot candle. The math is right? Chris, your math is right? 14.87. Any question why we added them, guys? This is foot candle from 1, foot candle from 2, foot candle from 3. I should, based on where I put them, probably I should switch these just because the way I'm writing it here. 3.23 plus, just to match what I'm writing here, guys, 8.35. So from 1, 3.23, from 2, 8.35, and from 3, 3.23, add them up. When you add them up, end up with 14.87, good to go. Any question? Yes, sir. Yep, only.
Are you adding, are you missing one piece?
This is from 1, from 2, and from 3. Which one am I
You're
missing?
missing 3.
I thought we did 3 symmetrical to 2. We're only, guys, this is calculation at point B, right here, from the 3 fixtures. Don't worry about A yet, or C. We're doing everything that I've done right now, everything that I've done is only at point B. Not A, not C yet. Not A, not C yet.
Yeah, your answer includes a 0.05 for,
Not the other side yet.
yeah, 14.87 does include that. No,
Okay.
she wrote it down ahead of it.
14.87 includes what?
Includes the spill over from a third line in. Kilo 71.
If we add all these numbers, would it add up to 14.87?
No. It's off a little bit, I mean.
Off a fraction is not going to make a difference, but it's off substantial, big deal.
No,
3.2,
it's off a little bit.
3 times 2, 3.23 times 2 plus 8.35 equal 14.81. 14.81. Okay, let's put 1. That's 14.81. Not a big deal. There you go. Okay, 14.81. The contribution from all these fixtures. Okay, let's go find, this is at B. Can we guys go and find it at a different point? At A. Let's go at point A. I want to remind you that we've done it at point P. We've done the calculation, all the calculation that we've done them so far at point B. We're going to go and do the calculation at point A. And if an A and C are identical, symmetrical, so if I find it at A, guess what? All the calculation at C will be at the same. So I'm going to go do calculation at point C. So I'm going to do calculation from 1 to C, from 1 to A, 2 to A, and 3 to A. Can we look at the symmetrical and try to cut on all the calculation from 1 to A? Do you guys agree with me? From 1 to A is going to be identical like from 2 to B? Okay, no calculation needed. How about from 2 to A? Do you think it's 2 to A contribution is identical to 1 to B? Because it's symmetrical. So 2 calculation already done. The only last calculation that I need to do is from 3 to A, because that's a longer way, longer distances. That's I need to calculate. Cool? Everybody see that? Okay. Let's go back. Okay, foot candle at point A. Now we have a point A, we need to find a foot candle. Foot candle from 1 at point A, the angle is 0. Right? So my angle is 0. And my angle is 0. And since it's 0, guys, you're going to find, I'm going to do the calculation, but you really don't need to do the calculation. You know the answer. 0.8 949. Multiply this by cosine 0 raised to the power 3 divided by 10 times 10, and that should give you an 8.35. And I said here identical to from fixture 2 to point B. Identical. It is, you don't need to do the math. You could have written to me, Chad, it's identical to contribution of fixture 2 at point B, and wrote immediately 8.3, and you're good to go. Any questions about that? Any question? Jackson, my friend, Ashley? So identical, if on the test, guys, if you said identical to contribution of fixture 2 at point P at point B, I'm okay with it and wrote the answer. But everybody see why they're identical? Because symmetrical triangles, symmetrical locations. That makes sense? Okay. Let's go from, now foot candle from 2 at point A. From 2 at point A, guys, I'm doing the math, but I really also don't need to do the math. From point 2 at, from fixture 2 at point A, you're going to have 10, the same thing, 10 over 10. And again, you really don't have to do that because it's symmetrical. Then you take 10 inverse, 1, right? 10 over 10, because the opposite over the adjacent of that triangle is 10. So that will, the tan of 1 equal 45 degrees. And we did the calculation for 45, guys. I'm just doing them for the heck of it. The contribution would be 0.88 multiplied by, at 45 is 1039. Multiply this by cosine 45 raised to the power 3. Divide everything by 10 times 10. And if you do the math, you should come up with 3.23. Because it's identical to, as I said, it's identical to another scenario that we have just done. Any questions guys about 8 foot?
Is it acceptable to just use the math? You don't really need to use the cosine and tangent to do this. As long as you have the horizontal, vertical.
Oh, you find D and you do that math when D? Yeah.
Then that way on the calculator.
Yeah.
It's a
Yeah.
arithmetic, really.
So you do the, you do,
Then you're not doing a lookup.
absolutely. You can. You do the D, that's fine. Instead of using the height, you can use the one that has the D. That's fine. The reason why they go by the height, because the height is typical. You know the height most of the time over
No, I'm just
fixture.
saying you don't need to do the
Cosine.
trig functions when you can just do arithmetic.
When you do 10, yeah, you do Pythagorean theory and find D. That's what you're referring to.
Yeah.
Absolutely. Any question, guys, about the contribution of fixture 2 at point A? Exactly like the contribution of fixture 1 at point P. Okay, the last one, Dustin, does it make sense? Okay, the last one we're going to do, this need math. The last one, guys, is the contribution of from fixture 3 at point A. Fixture 3 is located right here, and point A is located right in here, and in between is point P and point C, just to orient you, right? So I showed the triangle that you're going to draw. So if you guys look at this one, we have the height is 10, the triangle, this side is 20, 10 plus 10 is 20. So then I need the cosine of this angle. The cosine of this angle equal 20, I need the tan over 10. That will get you a 2. And if you take the 2 inverse tan over 2 equals 63 degrees. Or if you want to use the method of finding the from Pythagorean theory, finding the hypotenuse here, square this, square the 20, and take the square root of them, find D, and do the formula, the D formula. That's fine. You should end up with the same answer.
Yeah, the D formula still uses trig function. But it's easy to use trig.
Okay. So you can use it without using any trig function. Okay.
That was my first and last one.
Okay. Show me when we're done, will you? Okay. Any question guys about this one? Tan Q3 tan inverse 63. Any question about finding the tan of the angle 63? Okay, so if you take the 63, guys, 63 degrees to page 50, page 5.3, if you don't have, if you go there, we don't have 53. We have 50, I'm sorry, we don't have 63, we have 65. So either you do interpolation, or for the test, for simplicity, I would like you guys to go to the next number. What's the next number? This is Chad's rule. In a real lighting certified calculation, you have to do interpolation. We're not going to do interpolation because we use a software anyway for this calculation. This is just method. So we're going to go 65 degree. Go to the next. The next will be 65. In this case, give you a little bit more than what you asked for though. And from here, from the 65, guys, if you go to the 65, it will give you the contribution is 780. The contribution is 780. Right? Contribution 780. And then piece of cake now. The foot candle equal 0.88 multiplied by the 780. Multiply this by cosine. Since I'm using 60, well, this is where if you're picking it up at 63, picking the value, since the angle, I know I use the contribution of 65, but I use the angle 63. I know it's goofy, so the contribution of 63 raised to the power 3, and we really have to do interpolation though, but I always, this is really approximation method anyway, unless you do interpolation. So what I do is I use the same angle that I got, but because I don't want to do interpolation, the lumen from the closest. So just do it for Chad this way. If you do a 65, we wouldn't be far away from the truth. Anybody try and see what you come up with. So 63 cubic at 10 to the power 10 to the power 2. And if you guys did that, baby, you're going to end up with 0.64. You're going to end up with 0.64 foot candle. Not a whole lot of foot candle, 0.64 foot candle. You can see that when you move 20 feet away from the fixture, your foot candle went way down. Your foot candle went way down.
Is there interpolation method? Is that linear? Or is it algebraic?
It's more or less just trying to decipher.
It's a linear. If you're doing the slope of it, you take the slope of the two values.
Like,
yeah. I don't want to do the interpolation because we went into it one time. Linear based on the slope.
Algebraically or
No.
geometric.
I think the one that I'm familiar with is a linear one. Okay. Any question, guys, about the contribution at point from fixture 3? Any question about the contribution from fixture 3? So the last thing you need to do is add them up, right? We need to add all these contributions. So the contribution from 1, 2, and 3 would be 8.35 plus 3.23 plus 0.64, right? See, these are the three contributions, and if you add them up, you end up with 12.22 or something similar. 12.22 or something close. Any question, guys? Any question about the light at point A? The light at point A. From all the fixtures, from all the contribution of all the fixtures. Now, a lot of people, my friend, you can imagine what Visual have done for all the fixture that we did outside and the contribution from every fixture at every angle at every point. That's when you guys were putting 2 by 2, that grid, that's taking the corner of every 2 by 2 and putting a calculation on it. Okay. So, without further ado, my friend, now Now, total foot candle at point C. At point C, since point A and point C are symmetrical, I'm going to go take you back all the way to our graphic. Symmetric. Take advantage of symmetrical. Since A and B and C are symmetrical in terms of contribution, if you look from 3 to C is identical to 1 to A, and from 2 to C identical to 2 to A, and from 1 to C identical to 3 to A. Can you guys see the symmetrical? So do I need to go there, repeat the calculation again? No. So we're going to go back, back, and back, and back, and see total foot candle at point C is at 12.22, and because of symmetrical triangles, symmetrical shapes, symmetrical triangles. Any question, guys, about this? Any question about this example? Any questions? Does it make sense? No? Yes? The only thing I want to remind you guys when you do the calculation is if you don't land on an angle, instead of doing tabulation, just go to the next angle. But when you do the cosine, use the angle that you came up with. I would like somebody to use the different angle and see what's the difference in the answer is. If you don't land on that angle and don't do interpretation, your number is approximation any.
You use 65 is 0.5.
Yeah, I use 63. I picked the lumen at 65, but the angle is 63. I thought that's closer. I might be wrong. That closer to the truth, but it's not. Definitely is not the truth, because the truth is symmetrical. Okay. Any question, guys, about this? Any questions? The last thing I want to go over, and then I will stop, is vertical foot candle calculation. Everything that we have done, and you guys have a picture of this, everything that we have done right now, everything that we have done, Ashley, my friend, is called horizontal foot candle calculation. We do the calculation right at the horizontal level, right? If you guys remember when we were using visual, the conference room, there were wall wash lights that were supposed to throw lights at the vertical, right? This calculation does not get you the wall wash. The second calculation I'm going to do is going to get you they call it vertical foot candle instead of horizontal. Any question about the horizontal? How we found the contribution of all these three fixtures at 3 points? So 3 times 3, 9 calculation. You're supposed to do 9 calculation, but because of symmetrical, we end up doing 3 calculation or 4. 3 calculation, as a matter of fact. Really, in terms of calculation here, if you look at it, each one is going to need 3 calculations, so end up with 9 calculation. Here's how I can screw you up, guys. Not like I would do it, but I would do it. If I go give you a fixture, 70 here, and here's 100, and here's 150 here, and leave the same symmetrical, and give you 3 different curves to go to. 9 calculation you have to do. Or, to make things more interesting, if I give you a height 10, 15, 30, and leave it at this. Don't ask me why anybody will do something like this. So, but most of the time, this is what you're going to be encountering. The same height, the same type of fixture, symmetrical. Really, when you space them, you wouldn't space the poles, guys, 10 here and 15 here. Typically symmetrical. Typically. Any question, guys, about the horizontal calculation before I move into the vertical? For the vertical calculation, I only have one tiny little example, two points I want to calculate. Okay, take this. Now we're moving into an example that does a vertical calculation, meaning calculation foot candle on a wall, not on a floor, on a wall. Wall wash. You guys have that. Wall wash. The formula that we have to use in this case is CP sine Q over D squared. Sine, not cosine. The formulas that we have been using, guys, for the vertical, they use the sine angle. For the horizontal, they use the cosine. If you look at the formulas, we we changed them to have the height. So the first thing you need to realize is which formula am I supposed to use? You're going to be using a CP sine Q times GF divided by the distance square. Now I'm not going to do it, but you can. I'm not going to do it, but you can go and change the distance into the height of the fixture and do it with geometry. Like we did for the horizontal, we changed the D into height and we made the formula read the foot candle multiplied by cosine cubed over the height. That's because we played with the geometry, right? For this one, we're not going to play with the geometry. We're going to take the D like face value, and we're going to use the same answer will be. So that's why it's sine Q, not raised to any power, not raised to any power. Okay. That's so for the test, please write this one when I say vertical foot candle calculation. Make sure you grab this formula.
And do we need the MF in there as well?
MF maintenance only if it's not given, it's assumed one. Yep. If I give you an NM maintenance factor, you just multiply another factor here. Yep. Absolutely. Okay. Let's just look at this scenario that we have. Ashley, my friend, I have a fixture. The mounting height of the fixture is 10. I don't know if you guys can see from the symmetry here. The mounting height of the fixture is 10 feet, right, up to this point. And I want you to do and the distance, and I picked up a switch gear. Typically, guys, you have a switch gear here right in front of you. By code, you have to have a light that shines at the switch gear. And I want to, there's the light is right in here. And 4 feet away from it is a switch gear, and I hit this point, and I need to find the foot candle calculation right at this point from this fixture. So I need the height from here down, the height from here up, right, and the height of the fixture. That's exactly what we're doing. So I picked one point and hit me here, and the other one way on the corner, right, equivalent to the fixture. Do you guys see that? Using the same type of fixture that we were using. Because every fixture has to have its own photometric data. I'm using the same fixture that we use for horizontal to put it next to a wall and see how much light is going to throw on the wall. Okay, one more time. The height is 10. The fixture is the same fixture. It was 70 watt, I believe. The photometric curve is the same photometric curve, 5.3, coming from 5.3, page 50. The distance between the wall and the fixture, the horizontal distance is 4. The vertical distance, I need to find 2 points. 1 point right here, one right parallel to the fixture. The other point is 5 feet below, which makes it also 5 feet above, right in the middle. Now, can I choose multiple points I can do? Yeah, we just pick 2 points. You can pick as many points as you want. Any question, guys, about this scenario before we even do the calculation? Because if you understand the scenario, you're done. Calculation is just plugging numbers. Phil, my friend, does it make sense? Does it make sense? And the angle that we use is always the angle with the vertical. The angle that you use, here's a Q2 and a Q2 all the way and a Q1. So the angle that we use. Okay, so let's look at point 1. Do you guys agree with me that the point 1 here makes a 90-degree angle with the vertical? Everybody can see that? Point 1 makes a 90-degree angle with the vertical. Okay, cool. So at point 1, the Q equal 90. And from this fig, guys, if you can go fig 5.3.50 at 90, what do you get at 90? Contribution from that fixture, 8, right? Everybody knows where the 8 is. So the Q is 90, Q1. If you take it to fig 5.3, page 50, the 90, the lumen emitted from a fixture at 90 degree equal 8, not a whole lot. This fixture is not meant to lit the vertical. It's not directed. This is meant to, this particular fixture is to shoot down. So if it's little, don't worry too much because it's not meant to do that. Okay, any question, guys, where the 8 came to be? Right here, where the 8 came to be. Now we're going to plug the numbers. Let's go plug our numbers. So the first number you guys need to plug in is 0.88 multiplied by, I'm plugging in this stuff. 0.88 is here, then times 8 times sine, not cosine, sine what? Sine 90 degree, right? Sine 90, no raised to any power, divided by the distance. Okay, now what's the distance? We didn't do the distance, did we? Now we need to find the distance. I don't know if I did the distance in the back. Oh, we didn't do the distance. Let's go do the distance. Now I need to find the distance. I don't know what the distance is. The distance is not 4. From, can you see the triangle 5, 4, right? It makes a, this is the D. Oops. This is the D that we're trying to do right here. Right? Everybody can see from, oh, I'm sorry, from here. Yeah, and this one is D is easy, Chad. It's 5. Everybody can see the distance D1 is right in here, which is 4. Everybody can see the distance from here to here is 4, right? So 4 squared, where's 4 squared? 4 raised to the power 2. And if you did the math, and if I did the math right, this is easy calculation because the distance is 4. I end up with 0.44 foot candle. Anybody came up with something different? So D1, the distance actually is that one at 0.1. I was looking at 0.2. At 0.1, the distance is easy because it's the horizontal distance, right? Since the angle is 90 degrees, just how far away from the two pieces from each other, the light and the
So instead, before with the horizontal, we were doing the mounting height, but now we're doing the
Yes, we're using the. Can I use the mounting height? Yes, but you have to go plug the mounting height into this and change it. Okay. Any question, guys? Any question? So this, I'm going to call this one D1, just for the heck of it. D1. This is D2, 0.2. So D1, just for the heck of it, I'm going to say D1 equal 4. This will help me. D1, everybody knows why D1 equal 4. Okay, let's go to 0.2. At 0.2, guys, at 0.2, I need to find the angle though. At 0.2, I need to find the angle and the distance. I need to find the angle and the distance. Can you guys look at 0.2 right here? I need to find, it's a Q2 right in here, but what is Q2? Yes, sir.
Distance, if 42, it's supposed to be 4 squared. So are you thinking?
It's actually 4 square, but it looks 42 from here. It's 4. It's 4 raised to the power 2. Thank you. I just put it the 2 close to it. 4 raised to the power 2. 4 raised to the power 2. Did you come up with different answer, Phil? Yes, no? Yeah, okay. All right, so at 0.1, any question guys about 0.1 vertical? Calculation at 0.1 vertical. Let's do calculation at 0.2 vertical. At 0.2, I need 2 things. I need the distance, D, and I also need the angle, okay? I need the distance, D, and I need the angle. Let's find the distance, the angle. The angle of Q, right here, this is Q2. The tan, I'm using the tan, guys. The tan is, what's the tan? The opposite? Yes, sir.
Do you use the right angle from Q1 over there?
No, Q1, yeah. Q1 was for the right angle. Yep. For 0.1, it's the right angle, right? Can you see it's the right angle from here with this? Now for Q2, it's Q2 is right here, guys. Can you see the angle here? I have no idea what this angle is. That's my Q2. To find the Q2, you need to take the tan. Tan is opposite over adjacent, right? So 4 over 5, right? So to find the tan, 4 over 5, they'll give me 0.8. And then if you guys go find tan inverse, tan, or inverse tan, inverse tan 0.8, that will get you 39 degree, right? And from there, since I'm going to go to Fig 5.3, page 50, since I don't have 39, Chad Kearney said, you can go to the next if you don't want to interpolate. Any question why we went to 35? Well, I'm going to go to the next. I'm sorry. I told you to go to the highest, right? What's the next one after 39? 39, we're going to go to 45. Let's do the 45. 45. Sometimes it might be a good idea to go to the closest. I don't know. Since we're doing interpolation, since we're doing interpolation, would it hurt your feeling, guys, if we go to the closest instead of the largest? Closest? It's really approximation. So let's do that to the closest. It gives us some value anyway, closer to the truth. So let's do to the closest. If I have to go 39, my options are 35 or 45. Where would I go? I am at 39. My options are 35 or 45, and I need to go to the closest. So that would be 35. So let's do a 35. I actually did the math for 35 degree. Go to the closest without doing interpolation. Okay. From there, if you guys go to the 35, from there, why do we go to 35? To find the contribution. So from 35 degree, I can find the same, that I need 105.1059. That's my contribution at 35. This is from Fig 5.3, page 50. The same Fig that we've been talking about here. Fig 5.3 at page 50. That will get me a contribution of 105.1059. 1059. The only thing I switch to track on you guys is when you find the angle, if the angle is not in that chart, you have two options. You can either go to the highest or to the lowest or to the closest. If you want to do it right, you have to do interpolation. Interpolation from two numbers. You have a number between two numbers on one side. You can find the equivalent number between two numbers on the other side. We're not going to do interpolation, so do me a favor. When I give you that one, go to the closest. So wherever this 39 is closer to 35 than 45, because the table goes 35, 45. Yes, sir.
Should we go to the closest?
Always go to the closest, regardless of highest or lowest, just for the approximation.
I want us to have a kind of calculation using the calculation.
If you want to do interpolation, I can do it one-on-one with you. I don't. It's not part of what I do. I can do it one-on-one with interpolation. It's just. I mean, if we're still doing it by hand, I will do it. I don't want to spend the time. This is just to give you the idea how they do it. Yeah. If you're going to be lighting, certified lighting designer is most likely will be tested on it. Okay. So the last thing, guys, I'm going to go put these together in a formula, right? Because without putting in a formula, it's meaningless. Still, we need to find the d, the distance. Remember, we need a d. If you guys look at the triangle here, I have my d here. If you look at the triangle, distance, I have a 5 and a 4 sides of a triangle. I need to find d2. Here's my d2. So from Pythagorean theory, if you remember, d2 equals square root of 4 to the power 2 plus 5 to the power 2, and that will give me what? How much? 6.4. 6.4, right? Is that what I got? 6.4. Everybody knows Pythagorean theory, right? The hypotenuse equal the square root of the squares of the other two sides added, right? You square the other two sides, add them up, take the square root of them, that will get you the hypotenuse. Okay, so since I know the D now, it's piece of cake. Go plug them in. And so foot candle 2 equals 0.88 times, what's the contribution? 1059 times sine. Now, which angle do you use the sine for? Since it's approximation, the actual angle that I found. Yeah, the 39. Approximation. 39, the actual angle. no raised up to any power, divided by 6.4 raised to the power 2. And if you do your math, you should come up, I came up with 14.3. Chris, what did you come up with? Okay. 14.3. Any question, guys? Any question about this calculation? Any question? So really not a whole lot to it. It reminds you with a few trig things that you have to remember, tan and cosine. On the test, please bring these formulas with you. If we're doing vertical, use the D, the one that has a D. If you're doing horizontal, use the one that have the height. If you want to convert the D to height, that's fine with me. Bring the formulas with you, plug them in. Pay attention to which angle are you talking about and which distance. That's the key point, is which angle and which distance. For the vertical, for the horizontal, the issue would be the angle only. Any question about vertical foot candle calculation and horizontal foot candle calculation? Okay, so this will be, guys, in our test number 2 as we go. I think not next week, the week after, most likely we'll do them. I will do one more example of this just before the test too. Okay, I'm going to give you a 5 minutes break, and as I promised the ones who were here earlier, guys, I would like to show you how to print from visual and import, and then I will satisfy my duty for the day. And then we're in the red line. Who's going to be doing red line, guys, next? Okay, can we do them, and then we'll do you guys? Okay, we'll do red lines. Rob, when you guys ready for red lines, we'll do red lines. Okay, thank you.